Hi, I'm Janam, and along with my teammate Nikhil here, we'll be talking about our project Image Caption Generation. First, we'll start to give a brief overview of the motivation for the project. The motivation for this project was that we can use this as the first step to enable alternate text for social media images and to provide captions for creative captions basically for social media posts, and also enable visually impaired people to better understand images in comic books or other news articles. Now, talking about what we've presented previously as our baseline model, we have a model that uses Inception v3 for the image recognition part and LSTM for the caption generation part, or the encoding and decoding part of an image to text. Now, as we can see clearly in the learning curve of the model, there are signs of overfitting since the validation loss is shooting up while the training loss is decreasing, and hence we try to optimize this in our approach. As we can see in the results of this model, the generated caption said a man is running through the water, while clearly we know that there are two dogs fighting in the snow. We also have a base reference of the alternate text generated by Microsoft Office, and they say that this image talks about a couple of dogs playing in the snow. Over to you.
Yeah, so in the next phase of the project, we decided to use a couple of ResNet models as our image feature vector generation models. So the intuition behind using a ResNet model was that they introduce skip connections in deeper convolutional neural networks, which give a better which avoid the problem of a higher training error in deep architectures as without any computational overhead. So here is the graph for the training and validation loss for the ResNet 18 model. As you can see that it is converging very well and there are no signs of overfitting here. So this is a prediction made on the same image by our ResNet 18 model, which says a dog is running through the snow, which seems quite accurate. These are the parameters that we used to train this model. So as you can see here, our blue scores are pretty decent here. So the next model that we used for the image feature vector generation was the wide ResNet 50 model. It also has a very similar learning curve as the ResNet 18 model. And you can see here that the caption generated here is also pretty similar, but the thing is that it has achieved better blue scores than the ResNet 18 model. So we decided to stick with the wide ResNet 50 model as our final model that we present here in this project. The thing is that we trained the previous model for 100 epochs, and these are the graphs that are generated by the final model, which was trained for 500 epochs. So as you can see here that from the validation loss curve, that our model is generalizing very well, and these are the blue scores that we achieved using this model, which are by far the best blue scores that we have got from any of our experiments. As you can see here, the unigram, bigram and trigram scores are all above 0.10, so which is very positive. And finally, these are some of the predictions that are made on just a couple of examples that we used to demonstrate how good our final model is. It is clear that it is performing very well, and these predictions are very accurate. So
so talking about some of the future work for our project, in this project we've mainly focused on modifying our approaches as far as the object detection part of the model is concerned. What we plan to do in the future is to use some other networks instead of an LSTM network, for example a transformer architecture, and also in the future try to use a more adversarial network to generate better captions for the images.
We would also would have liked to use the larger Flickr 30K dataset, which could be possible in the future with if we have better computational resources at our end. So thank you.
Thank you.